Good day, everyone. It is nice over here for you and I because learning never ends and education is the key to an impactful life. My name is Anthony Nathaniel.
Good day, everyone. In the previous episode, we've talked about elasticity of solids, but in this episode, we'll be dealing with the crystal structure at the fundamentals. Now, this crystal structure is something you need to understand wherever you are, whether you are going for engineering courses or you just want to understand it as a hobby or you want to use it to further your knowledge of material science. But this is crystal structure at secondary school level. It consists of the basics of crystals and how do you have your body-centered, cubic, and different structures of the crystals. So let's delve into the topic without wasting much time. Without wasting much time, let's begin to define what we attempt to talk about here, which is a crystal. Now, you've probably seen all those white particles of salt, white particles of sugar, and other salts. But these materials, these substances, they are all called crystals. A crystal is a piece of solid matter in which the atoms, molecules, or ions are arranged in a highly regular repeating pattern or lattice. So in this case, you have a regularly repeating pattern of molecules in that substance, and they have a pattern of repeating. So they kind of repeat this pattern till the end of the molecules. So if the molecule continues to infinity, so the same pattern will continue. So this is how crystals work. This is how they Now, folks, let's talk about the structure of simple crystals. Now, we have different types of crystals. We have simple crystals, we have space-centered cubic crystals, we have body-centered cubic. Now, but simple crystals are um, composed of a huge number of simple basic units or building blocks called unit cells. So as to pack or stack these unit cells up and down, side by side, in all directions, you can build the entire lattice. So this simple cubic lattice, in which the atoms or molecules are placed at the corners of imaginary tubes, stacked side by side, up and down like a building block. Such is the structure of sodium chloride. In its atom of sodium and chlorine, take at alternative position in a cube of each of three dimensions. So that means after a sodium ion, you get the chlorine ion. After a chlorine ion, you get the sodium. So they alternate together. Now each atom within the solid has 6 immediate neighbors. So that's how a simple cubic looks like. So basically, all you have is in your simple cubic, you have an atom at every corner of the substance. So now this structure allows for it to have 6 neighbors. Every sample substance has 6 neighbors. This is simple cubic, and a substance that exhibits this kind of behavior is the sodium chloride. So, but other compounds, they belong to other crystal structures. Apart from the simple cubic crystal we also have another structure, which is the face-centered cubic crystal. And in this case, the unit cell has identical particles at each of the corners, plus another in the center of each face. So as shown in this figure, you can see in this drawing, you can see this is actually zinc sulfide. So this is how it looks in the atomic crystal, and this is called a face-centered cubic crystal because it has atoms at each corner and at the center of each face. So that's why it's called centered. Now, finally, structure, which is known as the body-centered uh, cubic crystal, and the unit cell have identical particles at each corner plus one in the center of the cell, as illustrated in this diagram. So you can see that there are particles at each corner. There's a particle cell. There's an atom at the center of the. So it has at the corners and at the center. Now, if it were at the center of the face, we'll call it a face. Or if it were at the center of the body, we'll call it a body-centered cubic crystal. Now, even though we are supposed to be talking about crystals, let's deviate a bit and discuss non-crystals. Non-crystal structures or substances, they are called amorphous substances, and you can see how they look. They don't have any recognizable order of the atoms and the molecules, which are connected in random order, and they lack the regular arrangement of atoms. So they are said to be amorphous, that means without form. And these kind of substances, they behave oddly when they are cooled. So, but crystalline substances solidify at a constant temperature. So I will show you that. Now, this is what I was trying to say earlier. You can see that this is the cooling curves for amorphous substances. So the crystallization of the melted material never occurs because the molecules cannot be untangled before they are frozen. So the typical cooling curve is shown. The cooling of the liquid continues until the substance no longer has the ability to move, at which point we call it a solid. It is indeed a supercooled liquid, not a solid. So amorphous substances, they form supercooled liquid, not solid, because the molecules are so tangled that they cannot form an ordered structure to form a solid crystal when they are cooled. So this is the cooling curve. This is how it looks after time has passed. And amorphous substances, they also soften gradually when heated, unlike a crystalline substance like ice, which will solidly melt. So that is why that's why you can heat glass tubing in a flame to soften and bend it. So in summary, let's talk about the major things we've been doing about in this episode. We've been talking about solids, which can be divided into crystalline solids and non-crystalline solids. We also talked about a crystal solid, which is one in which the atoms or molecules or ions that make up the solid are arranged in a regularly repeating pattern. Now, at the end of this video, these are questions that are related to the topic. So you have questions 1 to 5. You can try them out and